Hello everybody, welcome again to my channel Moniverse. So in this video, we are going to see about the first come first serve CPU scheduling algorithm, and this is the part 3 video of CPU scheduling algorithm. Welcome to the video. So now we are going to see what is this first come first serve. So first come first serve is similar to that of standing in a queue. So while you are standing in a queue in person, the first person will be going and getting the things from the counter, followed by the second person and the third person and the persons it will be going on as per the order how they are standing in the queue, right? So the same method is followed in first come first serve. So there is no interruption of the process which is being executed in the processor by the incoming process. So probably it is a non-preemptive scheduling. So it is not, the current running process is not interrupted by the currently entering process. So that is called as non-preemptive, right? So if you have doubts in this non-preemptive and preemptive, you can watch out the part 2 videos of the same series of operating system where you can clearly distinguish between the preemptive and non-preemptive scheduling. So actually, this is the simplest scheduling algorithm. So we don't want to think about any methods or any hidden principles, or we don't have to go for any calculations for executing the process in a processor. So we are going to send the processes into the processor as per the order they are arriving inside the ready queue. So this is the first come first serve procedure, and it is also called as first in first out principle. Okay, so let us see. Let's consider the processes as per in this table with the arrival time, same arrival time as 0. So initially there are three processes arriving, P1, P2 and P3, with burst times 5, 3 and 8 respectively. So I have shown you the ready queue over here. The ready queue has the process P1, P2, P3 in the order they have arrived, and all have arrived at the same time. So now we can see how it is being executed. So the scenario 1, so the process P1 initially, which is in the ready queue. So now the processor is idle so that we can start executing, right? So now the process P1 enters. We all know the burst time of the process P1 is 5. So here 5 units of time it is going to take for execution. As it is a non-preemptive process, and the first entering item will be entering into the processor for execution. Now the P1 executes for the first 5 units of time. So once it get executed, it will be removing itself from the processor. Now in the ready queue, we are having two more processes, P2 and P3. So P2, it's time to enter. After entering, we can see the P2 is having the burst time of 3 units of time. So obviously, for 3 units of time, our P2 will be running in the processor. Once it completes the burst time execution, it will be moving outside the processor. Now only one process is left over in the ready queue, that is P3. It's entering into processor and it is having the burst time of 8 units of time. So here it will be executed for the 8 units of time. So with this, we have cleared all the processes which were waiting in the ready queue for execution. Hope you all have understood the FCFS. Now it's time to calculate the completion time, turnaround time, and waiting time of each process, right? So in the previous, while we are executing the process, we have completed the Gantt chart. So Gantt chart is nothing but this chart that is the timely execution of each process will be specified over here, which is called as the Gantt chart, right? So, what we are going to do is we are going to calculate the completion time. Completion time can be directly taken from the Gantt chart, which time the process has been completed, right? So, let's consider for process P1. So, P1 has completed at the time 5. So, the completion time of P1 is 5 and P2 is 8 and for P3 it is 16. Okay. So now we are going to write the completion time for everyone. So now, as we are writing the completion time, we are going to calculate the turnaround time also. So turnaround time, as we have seen in the part 1 video, we know that turnaround time can be calculated with the formula, the completion time minus the arrival time. So here the completion time is 5, right? And the arrival time is 0. So 5 minus 0, the turnaround time will be becoming as 5, right? So next one is waiting time. How much time? Waiting time will be indicating how much time particular process P1 has been waiting in the ready queue to get executed. So obviously, as it is as entered into the ready queue, it went inside the processor as it was idle. So the waiting time will be 0, right? So we are having a formula for calculating it. That is the completion time minus the burst time. So completion time is 5, burst time is 5. So 5 minus 5, it is 0. So the same way we are going to calculate for process P2. In P2, it is moving, the completion time is 8, right? So completion time is 8. So turnaround time is 8 minus 0. It is again 8 and waiting time, even though it has entered in the 0th second, it has started executing only after the 5th unit of time, right? So here is the formula, that is the completion time minus the burst time. So completion time is 8 second it has been completed for 3 units of time, right? So we have to subtract this 3 from 8. So now the answer will be 5. So for process P3, it is completed at 16 seconds. So the completion time is 16 unit of time, right? So turnaround time, we are calculating with the formula 16 minus 0 is 16, right? So turnaround time generally means that how much time it has been entering into the queue and it is exiting after execution from the processor. So 0th unit of time it has entered into the ready queue and it has been executed up to 16 and it has spent its time by waiting in the waiting queue, sorry, ready queue and in the as execution in the processor, right? So the total time it has taken inside the queue and the processor is 16 unit of time. So now we are going to calculate the waiting time. So waiting time, it has arrived at 0 seconds and it has waited up to 8 seconds, right? Just keep it in your mind. I'll be just mentioning a second or unit time. It can be microseconds depending upon the computer. So that's why in most of the places I'll be referring as unit time. That unit can be of any number, right? And here, as per the formula, that is turnaround time minus uh, burst time, 16 minus 8, it is 8, right? So hope you all have understood how to draw the Gantt chart, how the process is entering from the ready queue to the processor, and then it has been executing, and finally the calculations of this completion time, turnaround time, and waiting time, right? So this is a very simple algorithm and it's very easy to execute and it's very easy to calculate. So I kindly keep it in your mind. You have to be very clear in drawing the Gantt chart so that the calculations of the turnaround time, waiting time, completion time, everything can be done very easily. So I think so. And finally, once we calculate that, we have to find the average values. Hope you all know how to find the average values. We have to add these three values and we have to divide it by 3 as there are three processes. Okay, so P1, P2, and P3. Fine. So 5 plus 8 plus, so this value will be got from 5 plus 8 plus 16 and it is divided by 3. The same way you have to calculate the average waiting time. 0 plus 5 plus 8. So divided by 3. As there are three processes, we have to divide it by 3. So we'll be getting the answer as 4.33. Right? So this is the thing we have to do or the computer is performing inside while processes are being executed in the first come first serve model. Hope you all have understood what is happening in first come first serve with the small animated representations. And kindly give your doubts, which I'll be solving. Specify all your doubts in the comments and please like, share, and subscribe my channel. Thank you.